Okay, now we're going to look at the timer interrupt programming. Okay, previously we already done the external hardware interrupt. So now kita nak tengok macam mana nak buat timer interrupt programming. Okay, so as I mentioned earlier, in Amiga 32, there are 3 timers. Okay, which is you have a timer 0, timer 1, and timer 2. And each of these timer here have a 2 type of methods. Okay, one is a overflow method, and the other one is a compare mesh method or CTC method. Okay, so this overflow and compare mesh method, you will learn more details in the next module. Okay, again, macam yang saya kata sebelum ni, as I mentioned earlier, timer 0 and timer 2 are a 8-bit timer. Okay, the punya size adalah 8-bit, but timer 1 is a 16-bit timer. Okay, so since we have 2 type of timers here, okay, which is satu by using the overflow method, satu lagi using compare mesh. Okay, now we're going to see how to do the program for both methods here. Okay, so before that, okay, kita kena tengok dulu lah dia punya step-step that you need to do, okay, you need to follow in order to write a timer interrupt. Okay, so similar to external hardware, the first step yang kamu kena buat ialah include this header. Okay, so this is the first step, include avr/interrupt .h. Okay, then after you include this timer head, include this header, lepas tu kamu, apa yang kamu nak kena buat ialah, okay, you do the main program, initialize your input output port. After you initialize the input output port, the second step, kamu kena enable your interrupt register. Okay, so dia ada 2 tempat to enable interrupt. Satu dekat TIMSK, okay, according to the timer lah. Timer dan method apa yang kamu guna. While B, okay, kamu punya status register. Status register ni dekat kamu punya iFlex lah. Okay, similar to this one. Macam mana nak enable dekat iFlex? Okay, simply write SEI followed by bracket and semicolon. Okay, then step number 3. Okay, so this step number 3. Then after that, you need to do the timer setting. Okay, so sebelum ni tak ada timer setting kan? So now you need to have the timer setting inside of your main program, of course. And step nombor 4 barulah kamu punya ISR. So we have another extra step here, which is we need to do the timer setting. Okay, so let's go back to our slides. Okay, kita tengok balik kita punya slide. Sorry, not this one. Okay, so let's look at the rollover. Okay, programming timer interrupt by using a rollover or overflow method. If the timer interrupt in the interrupt register is enabled, okay, the timer overflow flag TOVX is raised. Okay, whenever the timer rollover and the micro P jump to the interrupt vector to service the ISR. So every time kalau ada overflow to your timer, what you call here, to your timer counter, so what happen? The flag will be raised. Okay, flag akan jadi 1. Okay, the timer rollover flag will set 1. Okay, so this TOVX flag will be raised whenever there is overflow occurs. Okay, so the details on how the overflow occurs, how the compare mesh occur will be given to you in the next module. Okay, so to enable the interrupt for a given timer, we must set the TOIEX bit that held by the TIMSK register. Okay, so according to this TIMSK register, you need to enable it accordingly lah. Contoh kalau kamu pakai timer zero overflow method, okay, you need to enable dekat bit kosong, timer zero CTC method, compare mesh method, you need to enable dekat bit 1 dan seterusnya. Okay. To enable the timer interrupt, let's say timer 0 will should write as follow. Okay, TIMSK equal to put 1 to your TOIE0. Okay, ataupun you can simply, okay, so this is a timer 0 overflow method. Okay, TOIE0, this is actually timer 0 overflow method. Or you can simply enable it by using the writing the TIMSK sama dengan 0B00000001 pun boleh. Okay, as long as the kedudukan is correct, then you good to go lah. Okay, and then after you enable dekat TIMSK, then you need to enable dekat status register by adding this. Put here SEI bracket followed by semicolon. Okay, so recap again, this is your TIMSK register. Okay, no need to remember as long this table here. Okay, because this table will be given to you. Okay, as you need to know how to read this table. Okay, let's look at this example. Kita ada a few example kat sini. Okay, write a program to enable timer 0 overflow interrupt. Okay, so macam mana nak enable timer 0 overflow interrupt? Okay, so again, kamu refer to this table here. Okay, timer 0 overflow interrupt is dekat sini. Okay, so what you going to do here is TIMSK. This is A sama dengan 0B 00000001. Okay, and then B, disable the timer 0 overflow interrupt. Macam mana nak disable timer 0 overflow interrupt? Okay, you can simply write TIMSK. Nak disable, you can put 0. Okay, so 0, 0, 0, 0, 0, 0, 0. And C, show how to disable all the interrupt with single instruction. Okay, macam mana kita nak disable semua interrupt guna satu instruction saja. Okay, because earlier, okay, to enable the interrupt, we need to enable dekat dua tempat. Satu dekat timer interrupt, okay, which is dekat TIMSK, and satu lagi dekat status register. But now you're going to disable all the interrupt by using one single, what you call here, one single coding. Okay, so to do that, okay, you just disable dekat your status register, because this is the, by using the CLI, so what happened here, you're going to disable interrupt globally. So all the interrupt will be disabled. Even though you enable interrupt dekat timer 0 overflow, tetapi since you put the CLI here, the whole interrupt will be disabled. Okay. So let's look at this example. Okay. Okay, you're going to write a program. Okay. That use timer 0 to generate a square wave on pin port B pin number 5. Okay, while at the same time, data is being transferred from port C to port D. Okay, so main program kamu, this is your main program. Di mana data akan dihantar daripada port C. Whatever you key in port C akan display dekat port D. And satu lagi, the interrupt will occur, okay, to generate a square wave dekat pin port D5. So it is the square wave. Okay, so since it is a square wave, you know that you're going to do a toggling process lah dekat kamu punya interrupt. So you have two program here. Satu main program, di mana main program ni port D sama dengan port C. Whatever you key in port C akan dihantar ke port D, while interrupt, timer interrupt, okay, so timer interrupt kamu adalah buat square wave. Okay, so how to do that? Okay, so this is the solution lah. Okay, first, apa yang kamu nak kena buat? Okay, so kita kena ikut dia punya ni lah. Okay, the step by step. Okay, step nombor 1, include the header. Okay, hashtag include avr/io.h and include avr/interrupt.h. So this is your first step. Okay, include the interrupt.h file. And then after that, lepas tu nak buat apa pula? Okay. Next, kamu start dengan kamu punya main program. int main void. Okay, open curly bracket and close curly bracket. Okay, dalam main void ni, okay, first, mula-mula kamu nak kena buat apa? Sebelum kamu enable the interrupt, okay, you need to initialize the input output port. Okay, dekat sini kamu nampak ni port C sambung kepada switches, port D sambung kepada LED, port B produce a square wave. So you can know that port B dengan port D, this is your output, port C is your input. So initialize lah DDRC sama dengan 0. Okay, so port C input. Okay, since this is an input, then you need to enable pull up resistor. Okay, then port D, the whole port D as an output. So DDRD OXFF. And satu lagi port C, port B pin number 5 ataupun kamu jadikanlah semua sekali lah DDRB sama dengan output as well. Okay, port D and port B sama dengan output. Okay, kamu dah initialize. Okay, next, after you initialize the input output port, then after that kita akan enable kita punya interrupt. Okay, two place that you need to enable interrupt. Satu dekat TIMSK, satu lagi dekat status register. Okay, for the TIMSK, so in this one here, you're going to use a timer 0. Okay, so contohlah kalau kita nak pakai timer 0 overflow method. Okay, so what would be the value that we need to put dekat TIMSK? Okay, so 0B 0000 0001. Okay, so timer 0 overflow. Okay, if you're going to use the timer 0 compare mesh, then you need to put 00000001. Okay, so make sure that the setting is correct lah. If the setting is not correct, then the program will be wrong. Okay, then after that, the enable dekat sini. So next kita nak disable dekat I flag by using the SKEE. So this is your step number 2. Okay, so this is step number 1. Step number 2. Step number 3, timer setting. Okay, so timer setting. Okay, I just put this step nombor 3. I just put something like this lah. Okay, timer setting. Okay, because this timer setting, you will learn more detail in the next module. Okay, so untuk yang ni saya just put the timer setting. So this is the timer setting lah. So I'm not focus on the timer setting. Okay, I'm going to focus how to write the timer programming only. Okay, timer setting nanti kamu nak tahu dia punya setting dia macam mana, then kita akan belajar next module. Okay, after you did the timer settings, and then lepas tu kita punya while loop. Okay, inside of this while loop, jangan lupa kita ada ni tadi, main program. Okay, so this inside of this while loop kena ada this program here. Okay, baca port C masuk kepada port D. So you can simply write port D equal to port C. Whatever port C you give at the port C will be displayed on the port D. And then close curly bracket. So this is the main program. Okay, we have finished the main program. Okay, then step nombor 4 barulah kita kena buat kita punya interrupt service routine. So this is step number 4. Your ISR. Okay, so ISR, make sure that the name of the ISR is correct lah. Okay, macam mana nak tahu ISR correct? Okay, since this one here you pakai timer zero overflow, refer balik dekat table tadi, timer zero overflow. What is the name for the timer zero overflow? Timer zero. Okay, so this one here, timer zero underscore OVF underscore vet. Okay, make sure that the name is correct. Timer zero underscore OVF underscore vet, open curly bracket and close curly bracket. Okay, and then nak buat apa dalam ISR tadi? Kita nak buat square wave. Okay, so what you're going to do here is, so you just simply write port B sama dengan port B, okay, exclusive of bit nombor 5. Okay, so this is what happened. Okay, and then satu lagi kamu kena, kalau kamu nak keep continuously doing this toggle here, so you need to set lagi lah kamu punya timer here. The setting of your timer you need to put inside here as well. Okay, kalau tidak dia hanya akan berlaku sekali sahaja. Unless you using the compare mesh. The compare mesh can run periodically, okay, continuously. But if you use the overflow method, dia hanya berlaku sekali sahaja unless you set the setting back. Okay, so this is the program. Okay, next for the compare mesh. Okay, so by using the compare mesh, periodically, okay, kena berlaku continuously and periodically. Okay, so to do that, you can use the compare mesh method. Okay, the program can be written using a CTC mode or known as a compare mesh method. Okay, so to do so, load the OCR register with the proper value and initialize the number to the CTC mode. Okay, when the content of your TCP mesh with your OCR, the OCR flag is set, which causes the compare interrupt to occur. So this is what happened. Okay, so this is your TCNT. TCNT is your counter register. If the value of the counter register sama dengan value OCR ni, so what happened? Bila value dia sama, interrupt akan berlaku. When the interrupt berlaku, so it will go to your ISR. And then after that, it will reset back the timer until the TCNT sama balik dengan OCR. So this will done periodically. Okay, so tak apa. Details macam mana nak apa tu TCNT, apa tu OCR, kamu akan belajar in the next module. Okay, so this is similar to what we did earlier. Okay, using timer 0, tapi sekarang ni using a compare mesh timer flag. Write a program that toggle port B5 every 40 microseconds. Okay, so kamu nak buat yang ni, toggling ni 40 microsaat. So 40 microsaat untuk this one, another 40 microsaat untuk lower, 40 microsaat untuk higher wave. Okay, and then while at the same time transmit data port C to port D. Assume that the external is 1 megahertz. Okay, so this is how you're going to write in the C programming, and this is how you're going to write in the C programming. Okay, this is assembly and this is a C programming. Dia sama je dengan yang tadi. Okay, cumanya dekat dia punya setting ni berbeza. Okay, dekat sini beza. Okay, so sekarang ni, sebab tadi kita pakai overflow kan. So sekarang ni you need to change here. TIMSK sama dengan 0B00000010. Yang ni je kamu tukar. And then step yang lain semua sama. Step nombor 1 sama. Initialization pun sama sebab dia benda yang sama. Okay, buat benda yang sama tapi cuma guna method yang berbeza. Okay, dekat timer setting ni of course lah dia akan berbeza. Okay, sebab compare mesh dengan overflow setting dia berbeza. Okay, and then while loop, dalam while loop ni kamu akan buat benda yang sama di mana port C, wherever you read from port C, you send it to port D. And then normal pipe, okay, yang ni lain. Okay, name kat sini. So sekarang ni kamu kena tukar jadi timer 0, okay. Tak pakai lagi OVF ya. So sekarang ni kita tukar dia jadi apa ya? Saya pun tak ingat. Okay, so you need to refer to this one ya. COMP, COMP ya. Compare mesh COMP. Okay, so tukar dia jadi COMP underscore vet. Okay, yang ni sama, do the toggles. Okay, tadi kita kena buat setting kat sini kan? Okay, kena setting balik semula di sini, betul tak? So now, no need to do this setting. Okay, just yang ni je. Line yang ni je perlu ada. Yang setting tu tak perlu. Kalau kamu tengok kat sini, if you see this line here, see, there is no setting inside of this ISR. Okay, cuma yang beza dekat sini, the setting here and then this name. Yang lain semua sama. Okay, sorry. Tadi bukan mana yang tadi yang ni tadi saya tersilap. Bukan port D sama dengan port C ya. This is a pin C. Minta maaf sebab ni kita baca daripada switches. So switches kita kena guna pin, bukan port. Okay, every time you read from the switches, you need to use the pin register. Okay, if you're going to send out the value to the output, then you use the port register. Okay, so any question up until here? We have finished the timer programming. Okay, either by using the CTC mode or overflow methods. Kita dah siap bahagian tu. Ada soalan tak? Okay, if no question, then we go to the interrupt parity and interrupt inside interrupt. Okay, so what happen kalau ada dua interrupt berlaku serentak, apa yang berlaku? And kalau ada interrupt tengah run and then another interrupt want to trigger, boleh tak interrupt? Okay, the second interrupt trigger. Okay, so let's look at the interrupt priorities first. So what will happen when two interrupt are activated at the same time. Okay, saya dah bagi tahu dah earlier. Okay, if the two interrupt is activated at the same time, then what you need to do is you need to see the priority. Okay, yang mana have the highest priority. Okay, so the one that have the highest priority akan respond first. Okay, for example here, if two interrupt are activated at the same time, the interrupt with the highest priority is first serve first. Okay, the priority of the interrupt can refer to interrupt vector table. Okay, which is related to the address in the interrupt vector table. Contohnya kalau kamu ada INT0 and INT2, you press the both switch together at the same time. So what happen here is INT0 akan trigger. Okay, because INT0 nombor kat sini ni, dia punya address dia lagi kecil berbanding dengan ini. So it has higher priority compared to INT2. So the INT0 will be triggered. Okay, so this is for the interrupt priority. Okay, then next question is interrupt inside interrupt. So what will happen if a AVR is executed and ISR belong to an interrupt and another interrupt is activated? Okay, contohlah. Sekarang kamu tengah run interrupt A. Okay, belum habis lagi interrupt A, suddenly you request another interrupt B. So what will happen? Okay, so jawapannya ialah when AVR begin to execute, okay, so what happen to interrupt B? Boleh tak dia interrupt B to berlaku ataupun tak boleh? Jawapannya tak boleh. So only interrupt can be executed at one time. Tak boleh dua interrupt berlaku dalam masa yang sama. Means that program interrupt pertama tu tak boleh stop. Lepas tu masuk buat interrupt kedua. Tak boleh. Kena tunggu dulu interrupt pertama habis. Then after that, kalau ada request untuk interrupt kedua, baru boleh dilakukan. Okay, baru interrupt dua boleh trigger. Okay, kenapa? Sebabnya, when AVR begins to execute an ASR, okay, every time the AVR that execute ISR, it disable the I bit. Kamu nampak tu, dia disable I bit in status register. Okay, what is the condition untuk interrupt berlaku? Dekat step nombor 2, both interrupt registers either dekat GICR ataupun dekat status register kena enable. If salah satu disable, so what happen? Interrupt tak boleh berlaku. So this is what happen lah. Okay, that's why the second interrupt tak boleh trigger. Sebabnya bila mana the AVR currently execute the interrupt service routine, it automatically disable the I bit in status register, causing all the interrupt to be disabled. So bila I bit dekat status register kosong, so maksudnya kamu dah globally disable all interrupt. So if you request an interrupt, that interrupt will never occur. Those no other interrupt occurs while serving to the interrupt. Okay, when you exit from the interrupt or when RETI is executed, okay, when you finish from this ISR, the AVR will automatically enable the I bit in status register. Okay, bila masa je kamu exit from ISR, so contohlah this is your ISR. Okay, so you do all the ISR. Bila mana je you run this close curly bracket here, atau this is for the C program lah, ataupun RETI in the assembly language, what happen here, the AVR will automatically enable I bit in status register. So I automatically become 1. Okay, causing the other interrupt to serve. Okay, so bila ni satu, so maksudnya now you can trigger any interrupt because you already disabled dekat status register as well as dekat your interrupt punya register earlier in the at the top of your programs. Yeah, so this is the answers lah. So cannot do interrupt inside interrupt. That one will never occurs. Okay, any question? So actually we finish our interrupt programming. Okay, kita dah siap dah interrupt programming. Okay, so now what we're going to do here is we're going to see the previous final exam. Okay, we're going to do some example of the previous final exam and previous test on the interrupt programming. Okay, so let's look at the first example here or the first exercise. Okay, you are asked to design a decorating lighting system with 8 LEDs for a client. Okay, kamu kena buat a decoration system. Decoration system tu mengandungi 8 LEDs. The system will be placed on the front desk of the client shop to attract customer to their shop. The placement of the LED is in a row. Okay, so kamu ada 8 LED, so this is your LED. Dia disambung secara macam ni. Okay, the client also requests to have 2 different set of sequential which have the defined in the queue table below. Okay, dia minta 2 pattern. Okay, the first pattern here. Okay, so this is the first pattern. Kalau kamu tengok sini. Okay, so yang red color ni maksudnya LED turn on lah. Okay, the first sequence here, all LED turn on. And then you call a delay of 100 microseconds. And after that, the LED turn off. And then another 100 microsecond delay is called. Okay, so the delay between the blinking is 100 microseconds. So this one here, the pattern A is you're going to do the blinking LED sequence. Okay, while pattern B, pattern 2, okay, so this one here, some sort of a running light lah. Kamu nak buat running light di mana the first sequence, this LED, kosong LED 1 turn on. Okay, after 100 millisecond, this LED turn on while the rest turn off, 2, 3 turn on. Lepas tu 4, 5 turn on, 6, 7 turn on. So you have a 4 sequence for the pattern 2. Okay, the system use a microcontroller AVR Amiga32 with LEDs as output connected to port C. Okay, so in this kind of question, okay, better you draw your circuit. So you have an Amiga32. Okay, port C. Okay, di mana port C ni kamu sambung kepada LEDs. Okay, dia ada beritahu tak LEDs tu guna common ended or common cathode. Okay, kalau tak bagi tahu, so you can choose lah either you're going to use a common ended or common cathode. So this 8 LEDs ada 8 LEDs kesemuanya. Okay, use timer 0 to generate the delay of 100 millisecond. Okay, so timer 0 to generate a delay of 100 milliseconds. 2 external interrupt on INT0, INT2 will be used to choose the blinking pattern. So kamu kena pakai INT0. Sorry. Okay, kamu nak pakai INT0, akan pilih pattern. Okay, triggering the INT0 will be generate one pass of pattern 1. Okay, kalau kamu press INT0, pattern 1 akan berlaku. Kalau press INT1, pattern 2 akan trigger. Okay. Okay, lepas tu dia kata ni one pass ya, hanya sekali saja. Means that every time you press hanya sekali je yang sequence yang okay, means that every time you press the INT, the interrupt will trigger once. Okay, sekali saja. Okay, the CPU frequency is 1 MHz. Based on this information, write down your program. Okay, so INT0, INT2, 1. So you know that this is a PD2 for INT0. and PD3 untuk INT 1. Okay, so this kamu kena sambung kepada ni lah, active low switches. Okay, kenapa active low switches? Sebabnya okay, sebabnya the interrupt only trigger at low level. Okay, so what you going to do? Okay, kita dah ada PD2, P3 dan port C. Okay, so and then dia kata delay 100 millisecond. Contohlah yang delay ni kamu dah the delay of 100 millisecond given dia punya apa ni namanya dia punya subroutine untuk generate 100 millisecond dah diberi. Okay, because kalau dia cakap macam ni kamu kena calculate the delay. Okay, buat delay punya programming. But we not yet learning the timer zero punya programming. Okay, how to generate a delay. So we just assume that the delay subroutine already been given. Okay, so let's the delay subroutine name delay 100 ms dah diberi. So we only need to call this delay to generate 100 milliseconds. So what are you going to do? Macam mana nak buat? Anyone? Apa nak kena buat ni? So, apa nak tolong? Okay, so mula-mula, okay, kita dah ada all the information here. Okay, so we just follow the step dah yang kita tulis tadi lah. Okay, so this one here, this is all about the external hardware programming, interrupt programming. Bukannya timer programming, this is a external sebab kamu pakai INT0, INT1 to trigger this sequence. Okay, so first what you're going to do here is okay, so include avr/io.h. Okay, so include this file here. /interrupt.h. Okay, so this is your first apa ni saya panggil first step. Okay, so include this header here. Okay, and then after that, okay, started with your main program, int main void. Okay, open curly bracket and close curly bracket down here. So what you're going to do inside of this main program? Okay, first, before we enable the interrupts, so you need to initialize the input output port. Okay, in this case here, port C connected to LED, so automatically port C become your output port. So OX, FF, and then you see PD2 and PD3 is your what we call here connected to the switch. Okay, so you can simply write DDRT sama dengan 0B 1111 0011. Okay, so this is a PD2 and PD3. Okay, which is PD2 and PD3, you make it as a input port while the rest output port. Ataupun, okay, you can simply make the whole port D as an input port pun tak apa. Okay, and then since this one here is what we call here, okay, you initialize an input connected to switch, then you need to enable the pull up resistor lah. So port D sama dengan 0B 0000. Okay, only this part here get 1, the rest you put 0. Okay, then barulah kita masuk kita punya step number 2, which is enable kita punya GICR. Since this is a INT0 and INT1, okay, the value that you need to put here is 11000000. Okay, after enable GICR, okay, because we only going to, okay, the interrupt only do one, okay, they only trigger once every time you press the switch. So what you're going to do here is you need to set your MCU CR. Okay, 0B0000, and this one here you can use either falling edge or rising edge. Okay, kalau rising edge putlah 1111. Kalau rising falling edge 1010. Okay, so this is INT0 and INT1. Okay, then after that, barulah kita enable kita punya I flag dekat status register. Okay, and then make sure you have a Y1. Okay, dalam Y1 ni ada apa-apa program tak? Tak ada apa-apa program. Kita hanya tunggu bila mana this switch is pressed. So just leave it kosong je macam tu. Okay, so this is a step nombor 2. Okay, step nombor 2 kita dah buat. And now we're going to do a step number 3. What is the step nombor 3? What is step nombor 3? Okay, step nombor 3 adalah kamu nak buat sequence ni lah. Okay, so I just put here. Okay, so this is step nombor 3. First is kita buat dulu ISR untuk INT0. Since you have 2 interrupts here, you need 2 interrupt service routine. Satu untuk INT0, satu lagi untuk INT1. So first kita buat INT0 dulu, ISR. Okay, make sure that the name is correct lah. INT0 underscore vet. Okay, so open curly bracket. So what is the program that you need to put inside of this ISR untuk INT0? This LED pattern. Okay, since this is a common cathode, so to turn on this LED, you need to give 1. Okay, kalau bagi kosong, dia akan off. Okay, so the first pattern here is whole LED turn on. So, apa kamu kena buat? Okay, port C sama dengan 0B11111111. Okay, LED on. Okay, after the LED on, what are you going to do? Call delay. Okay, so we just simply write this delay here. Okay, so delay 100 ms. Okay, assume that this delay already provided lah. Okay, and then after that, the second sequence is the whole port C turn off. Okay, so port C sama dengan kosong, and then call again delay 100 millisecond. Okay, so this is untuk ISR INT0 untuk display pattern 1. Okay, now untuk INT1, di mana INT1 dia akan display pattern 2. So you need to have another ISR. So ISR INT1 underscore vet. Okay, make sure that, okay, so this is the third step lah. Okay, make sure that the name is correct lah. Okay, so next, macam mana nak buat display ni? Okay, hantar je lah value according to this sequence. Okay, the first sequence here is port C sama dengan 0B000011, and then call delay. Hantar sequence nombor port C sama dengan 0B 00 00 11 00. Call delay. Dan port C sama dengan 0B 00 11 00 00 and then call delay. And last but not least, the last sequence which is semua sekali yang ni pula turn on. So port C sama dengan 0B 11 00 00 00. Okay, and then call delay. Okay, jangan lupa call delay sebab the delay between blinking is 100 milliseconds. Okay, make sure that you call the delay and close curly bracket. Okay, so this is the program for what we call here for these examples. Any question? Ada soalan tak? Okay, if no question, I think this one here, okay, saya bagi kamu inilah kau punya assignment. Okay, so this is your second assignment. Kita dah buat first assignment and this is become your second assignment. Okay, sekejap saya copy dulu and then I give you to. Ada soalan tak? Semua? Any question? If you have any question, then you can ask me. Okay, if no question, I think we stop here and see you in the next meeting. Okay, so I will give you the assignment for the second assignment, individual assignment. Okay, you need to submit them before